So here we go then. Question 151, the first integration question with logs thrown in. So the first thing we're going to do is to integrate ln x with respect to x. So I'm expressing ln x as 1 times ln x. Why is that important? Well, what that does is it enables me then to use integration by parts where we're integrating a function times a function. But my choice of u and dv dx in integration by parts, if I chose this to be u, then du dx would simply be 0 and I wouldn't get anywhere. But if I choose u to be ln x, then when I differentiate u, I get something that hasn't got a ln in it, and that's very helpful. So I choose u equal to ln x, dv dx equals the 1. And then, of course, du dx is 1 over x, and v will be the integral of 1. So v is just x. There's the formula for integration by parts. So u times v is x ln x, and v times du dx is x times 1 over x. So this becomes x ln x minus the integral of x times 1 over x dx. X times 1 over x is just 1, of course, and the integral of 1 is x. So there we are. The integral of ln x is x ln x minus x plus c. So we've completed the first part of the question. So what about the second part of the question? Well, I'm going to write this integral slightly differently to make it a bit more obvious what I'm doing. I'm going to write ln x squared as ln x times ln x, and then I can use integration by parts again. The u and the dv dx are both the same, and so when I differentiate u, I get 1 over x. But integrating ln x, well, we did that in part A. The integral of ln x is x ln x minus x. I don't need to worry about the c. I'll add the constant of integration at the end. Well, I don't actually need to do that even, because this is a definite integral, so there's no need for a constant of integration. So when I put these things into the formula for integration by parts, I get u times v, which is, there's my u and my v with the limits, minus the integral of v, which is this, times du dx with respect to x. So then, having multiplied the brackets out, I've got just when I multiply these brackets out, I've got ln x minus 1. So I've got to integrate ln x minus 1 now. When I do that, I've got the integral of ln x is that, and the integral of 1 is x. So that's my full integration, and now I've got the limits to apply. I could, and I should perhaps have simplified this all before applying the limits, but I haven't done that. I've just applied the limits straight from here. So putting the upper limit in of e squared, that's in the first square bracket here, and then putting the lower limit of e is in the second square bracket here. So ln e squared, what is ln of e squared? Well, that's 2 ln e, which is just 2, and ln e is just 1. So this simplifies down. This bracket, for example, e squared times ln e squared is just 2e squared minus e squared. So this is just e squared, and this is 2 here. And then e squared times ln e squared is 2e squared minus 2e squared. So this bracket is 0. So this is just 2e squared minus 0. So we've got 2e squared here. And then here we've got ln e, which is just 1, times e ln e, which is e minus e. So that part is 0. And then we've got e ln e, which is just e, minus 2e, so that's minus e, but we've got a minus here and another minus here. So that's minus a minus minus is a minus. 2e squared minus e. So there's the confirmation. So a bit messy perhaps at the end there. If I'd simplified this before substituting the upper and lower limit in, it might have been slightly less messy. Okay.